Tuesday, you should know that Shape Patterns is due Friday. There's also a quiz this Friday, of which includes Jesse's career talk. The PowerPoint will be shared shortly. Announcements, Girls Who Code will start meeting, if not next week, the week after, room 332 on Mondays. Okay, so here's the PowerPoint. Right now, you need to know 3 key steps. We'll focus more so on variables. Variables you've seen before in math class, likely in some form of algebra. They represent a lot of that is similar, but parts of that are different when it comes to computer science and coding. So notice this first part. There's the declare step. You have to tell the computer, you have to tell readers of your program that variables exist. So the very first step, VAR, that's a keyword. You can also use let, L-E-T, that's similar to like math. This is how you tell the computer these variables exist by going var x, comma y. The x and y variables now are ready to store numbers. The second step, which happens in setup, that's the code that runs just once. You got to tell the computer, okay, now that x and y exist, where do they start? Initialize the variable is something you'll hear a lot of. So that looks like x equals 300, y equals 200. And at this point, by declaring and initializing a variable, anytime you see a number, you can replace it with like x and y. Like for example, if you're controlling ellipse position. And I think a lot of you have done that so far. The weird part is what I call the modify or the update step. This doesn't look like a valid equation in algebra class. X equals x plus 1 or y equals y minus 1. Y is on both sides. Then you get something like 0 equals negative 1, huh? So that has special meaning in computer science. This is updating. Right now, I'll tell you, like, it's telling x, please increase yourself by 1, then update yourself. Replace your old value with your new value. And I'll go in depth on what that means. If statements, especially for those that are in geometry or have taken geometry, your logic from that class that you've gone over, your truth tables, it's going to pay off now because that kind of logic applies for if statements. If then, also known as the conditional, is how you selectively run lines of code. Maybe you want, like your circle, to go to a certain place after you hit the edge of your canvas. Or maybe when the screen turns dark, you want to reset it to something lighter. These kinds of behaviors, if the screen or if the ellipse goes off to the right edge, goes off your screen, then I want to reset your position. Think in that ways, your code will be a lot easier to translate, or your thinking will be a lot easier to translate into code. So these are 2 big ideas that you will practice in shape patterns. My starter code has some examples, and some of you have been fiddling with that, and you're experiencing the capabilities of these 2 ideas. So you should be added to my code.org classroom. They do a good job of walking you step by step through first variables, then they introduce some randomness, and then later in lesson 11 they talk about if statements. They call them conditionals. And I highly recommend you look over them. I will borrow 1 or 2 of their examples and put it in your quiz on Friday. I especially like the daisy question, where they kind of make use of symmetry to draw a flower. Now, to keep your mind grounded in an analogy, so far you've thought about a paintbrush. Now I want you to think about a flip book. Flip books are how the draw function works. It gets drawn over again, you turn to a new page, that's your new canvas, new background, and then it draws itself. So we will walk through this short 10-second video. Keep this in mind when you're drawing your shape pattern. The background function being drawn is turning to a new page. This is basically what we're making the computer do to achieve an animation. And goes, done. Ah, take that. And thus we are happy. Eat the rainbow. Goodbye, grumpy cloud. Perhaps that'll happen today. Oops. So notice, right? Like over here, there's tiny changes drawn each frame. Water or like rain falls down from said cloud. Notice the cloud moves from left to right, right? Girl's emotion never changes, looks up, and then you have colors extending from the hands at certain positions. Okay, there's a lot going on, and breaking it up piece by piece is what these next couple of assignments will do to get you to get some cool animation going. Okay, I'm going to skip over that slide. Should I? Okay. So we'll go over this. When you were drawing your animal, a lot of you were doing the calculations in your head. For example, when moving something to the right, you added things to the x coordinate. When moving things down the screen, you added a positive number to your y coordinate, correct? And then after a while, you just kind of got used to it, or you looked at the mouse coordinates and did some calculations in your head. You can make the computer do that, and you can get some pretty neat effects. This is called using expressions. They're just like you see them in math class. You have some operators, adding, subtracting, multiplying, dividing. This is a new one. It's called modulus. It's especially useful in computer science. It's known as the remainder function. We will explore this later, but you should be familiar with add, subtract, multiply, and divide. So 5 plus 3, that's 8, just as before. We can evaluate these things following order of operations, and we get certain numbers. Now, how is that useful? We skip over this. Well, symmetry. So maybe in shape patterns, you want to create a symmetric like repetition of shapes expanding outwards from the center. It looks kind of cool. Or maybe later, something more complex, you want it to rotate or spin like a spiral about a center. You're going to probably make use of symmetry. So when starting with like the right ellipse, you want it to be mirrored across some line. Well, just add and subtract the same amount, and now they are like balanced, right? And you can just do this instead. Although they're still numbers now, this idea is going to come up really useful when you want it to be like symmetric by like a different length. Instead of replacing 75 with like 100, if you want that distance to increase, why not just do it once? Use a variable. All right, so onto that idea of variables. Mr. Simon always says it's a mailbox. So variables are mailboxes. So the mailbox must exist. That's that var num. That's called the declaration step. And in red, declare, declaration. You should be very familiar with that vocabulary. Formally in computer science, that's the same kind. Num is the name. That's what you call your variable. There's some special variable or special words that are reserved, kind of like ellipse, arc, setup, draw. P5.js has already reserved those because those already have meaning to them. When you're making your own variables, you are making meaning of other words. And so with variables, know that you can't have spaces or special characters every so often. The computer is going to read that differently than you do. So have them be like letters, numbers, underscores are perfectly fine, but like the weird ASCII characters, those aren't okay. Once you have that, once you have var num, once you've declared it, you have to give it meaning. That's the initialization step. Where does your variable start? In this case, we have the number 5 being stored into variable num, or into the, so 5 is the value that's stored into the variable called num. Now, anytime you see num, it has the value of 5. These first two steps, you can combine it together. You can declare and initialize all at once. Notice down here, on the left-hand side, you have var num. On the right-hand side, you see 5. And in between them is the equal sign. You can do both declaring and initializing. You could also mix it with expressions. But here's the important part. Down here, notice in red, the equal sign has a special meaning in computer science. It's called the assignment operator. And there is a difference between the left-hand side and the right-hand side. So notice here, 5 is stored into num. Over here, which is a really big mistake, is num is trying to be stored into 5. You can't do that. Num is your variable. You are the controller of its meaning. 5, it always means 5, either the word or either the string, the word, or like the number 5. So whatever is in the right-hand side is stored into the left-hand side. You can't go the other way around like we do in math class where we say both sides must be equal. Both sides are not equal here in that regards. 5 is being assigned into num. This will come up on your quiz. I'll ask you which one of these is an error, and it may come up. Okay, assignment operator. That's also vocabulary you should be familiar with because it may appear on your quiz. And I may use it every so often. Although I say equals, really it's the assignment operator. Some other pitfalls when you're trying to be more efficient, so thinking that, oh, if I can declare and initialize a variable at the same time, let's use it and put it in here. That's a mistake. You can't do all that at once. You have to separate it into two lines. Notice down here, var x equals 45. Now this ellipse will be drawn at x position 45, y coordinate 55 of size 10, 10 for the width and height. So we get a little circle. Okay, what does this word say? So here comes that last step, modifying or otherwise using a variable. This line has a lot of meaning. It's kind of hard to see, but it says x equals x plus 1. When var starts at 3, what do we think that x is if you have x equals x plus 1? You're thinking. So what happens here is 3 plus 1, you know that's 4. So at this point, after these two lines of code have run, x is equal to 4. Okay, that's a little weird, but it means a lot in computer science. You'll see it again and again. At this point, var x is 3. After this line has run, x is being updated to increase by 1. Down here, if you pretend you're the computer, x is equal to 4. And so, with that previous idea, with symmetry, now instead of having just one line of symmetry, by adding and subtracting both at once, you can make use of like 4 lines of symmetry. You can get some pretty neat patterns that way, which is the spirit of your next assignment. Notice offset is your 40. Whether you increase or decrease it depends on the operator, but your initial spot's kind of like this center, and then you have 2 lines, so it's reflected here, 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 and here. Variables can be reused anywhere you want, but in this case, I want this 40 to be the same kind of offset, same kind of change. That's why I get to repeat it. I get this as the output. Notice now, if I wanted to change it, notice like the spacing right here, 40 turns into 110. I no longer have to like delete, type 111, delete, 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 which I'm sure you did a lot of in your animal assignment when trying to fix things into certain positions, yes? We nod, right? So variables can save you a lot of time that way. Now, here's a quiz question, just focusing on those 3 steps of variables: declare, initialize, and otherwise update. So you look at the top, there's red. You look at the bottom, there's a purple color. Notice I have 2 variables declared, x and y. Where will these circles be drawn? There's a very subtle difference. So take a couple seconds. Guess either the top or the bottom one, and then I'll talk you through the answer. I can't see it. All right, so you're welcome to pause the video. At this point, I'm gonna tell you which picture matches. So what's happening here is, I hope you notice, this circle is being drawn first, second, and this is the third. So the difference is it drawn from left to right or right to left? And that matters. So let's take a look at x and y. If x and y start at 50-50, that should be this one, right? This circle. You add 50, so we move 1 to the right. This should be the second circle. And then you update x again, and you draw a third circle. So then it should be the red one up here. Okay, so one way to think about this is wherever you saw x, you replace it and update it accordingly. Notice this one, the right side happens first, then it gets stored into x, which is why x is drawn at 100 and then 150. Okay, and so that's all for today. That was a lot of talking. Just focus on variables. Tomorrow we'll build on this to get some pictures moving for if statements. The code.org lessons will do a good job of guiding you through, so if you want to get a little ahead, work on those. We've introduced variables. The key ideas, there's 3 steps: declare, initialize, and modify, update, or use. That's the 3rd step.